Hi, this video today will be about real number properties. I'll give you some notes, I'll describe each property, and then I'll give you some examples. Let's start with the commutative property. Now for each of the properties, I'm going to give you a word that I want you to associate with it. In this case, I want you to associate the word order with the commutative property. Order, because it doesn't matter what order you do the things in, you will still end up with the same thing. So let me show you an addition part and a multiplication part. I can separate most of the properties into two parts, addition and multiplication. Let's start with addition. For example, I can take 5 plus 2 and 2 plus 5, and I'll get the same thing. 5 plus 2 is 7, 2 plus 5 is 7. So even though I switch the order on each side of the equal sign, I still end up with the same thing. Multiplication, let's take 3 times 6 and 6 times 3. Over here on the left-hand side, I get 18. Over here on the right-hand side, I also get 18. It doesn't matter how I multiply, which order I multiply, because I still end up with the same answer, 18 and 18. So when you think of the commutative property, think of the word order, because the order doesn't matter. All right, let's do that in real-world terms. That last example was with numbers. Let's talk about it in real-world terms. Okay, so are these examples of the commutative property? In other words, does the order matter? So ask yourself that question when you're doing these examples. For number one, to pick up my coat and to put on my boots, well, it doesn't matter what order I do those in, because at the end of that, I will always have my coat in my hand and my boots on my feet, whether I do one first or the other. So in this case, the order doesn't matter. So in that case, that is an example of the commutative property. Order doesn't matter. All right, number two, hang up the phone and say goodbye. Well, let's imagine you're talking to your grandmother, and you hang up the phone, and then you say goodbye. Well, the next time you talk to her, she might be upset at you because you didn't say goodbye. So if you say goodbye and then hang up the phone, you get a completely different outcome. So in this case, the order does matter. So this is not an example of the commutative property. The order matters. Same thing with number three, to brush your teeth and to put toothpaste on your brush. I think your dentist would really care if you put toothpaste on your brush first. I think your teeth would be a lot cleaner. So this is not an example of the commutative property. It does matter what order you do those in. Okay, so that's the commutative property. Let's go to the associative property. Let's talk about a couple examples. I want you to think of the word grouping when you hear the word associative property. And some of you remember this probably from moving the parentheses around. And that's basically the thing here. All right, so let's start with 1 plus 2 plus 3 equals. Now in this quantity, I'm going to put 1 plus 2, and then I'm going to add 3 to it. Let's see if it matters. 2 plus 3 is 5, 5 plus 1 is 6. Over here, 1 plus 2 is 3, 3 plus 3 is 6. It doesn't matter how I group the numbers. It doesn't matter where the quantity is, I still get 6 on both sides. Let's do the same thing for multiplication. 2 times the quantity 4 times 5. Or 2 times 4 in a quantity times 5. 4 times 5 is 20, times 2 is 40. 2 times 4 is 8, times 5 is also 40. So it doesn't matter how the numbers are grouped, I still get the same thing. Associative property, think of grouping. Let's go to the identity. For the identity, I want you to think of the word same. What I start with is the same thing I end up with. Let's see an addition example. 7 plus 0 equals 7. I start with 7, I end with 7. It's kept its identity. Whatever I start with, I end up with the same thing. Let's talk about multiplication. 8 times 1 equals 8. Started with 8, ended with 8. I ended up with the same thing I started with. That's the identity property. Let's move to inverse. For inverse, I want you to think of the word opposite, because I'm going to undo the operation. Okay, so addition. Let's do 9 plus negative 9 equals 0. I undid what I started with, so I did the opposite. 9 plus negative 9 equals 0. For multiplication, I'm going to take 3 times 1/3. 3 times 1/3 equals 1. So I undid what I started with. Now if you end up with 0 or 1 when you're looking at these properties, most likely it will be the inverse property. Not always, but most likely it will. 0 means it's the addition part, 1 means the multiplication. So for inverse, think of the word opposite. Next property is the transitive property. Now this is similar to the law of syllogism from geometry, and if you remember that, this was the logic unit. You had if P then Q, if Q then R. Your conclusion was if P then R. Okay, now you probably associated words with that. You probably put that in sentence form, but that's the symbolic representation of the law of syllogism. The transitive property from algebra is very similar to that. Now you probably have seen it written this way. If A equals B and B equals C, then A equals C. Notice how the order of the letters is the same up here as it is down here. P, Q, Q, R, P, R. A, B, B, C, A, C. The middle symbols are the same. The outer symbols become the conclusion. Up here is the same thing. Transitive property is pretty easy to see because it's usually in the same form. Okay, let's move on to the last one. Now the last one is the distributive property. And the distributive property is pretty easy. I'm not going to spend a lot of time on this. Let me just give you a quick example. 3 times x plus 2. So you get 3x plus 6 after you distribute the 3 to both of the terms. Okay, and everybody recognizes the distributive property. You've done it 1,000 times in algebra. Okay, let's do some examples. Okay, let's start with 2 plus 5 equals 5 plus 2. Okay, so it looks like it doesn't matter what order I do them in. The order has changed, but it doesn't matter. I get 7 here, I get 7 here. This is an example of the commutative property of addition. Okay, let's try this example. It looks like the grouping has changed. And here I have 2 plus 5. Over here I have 7 plus 2. But it doesn't matter. I end up with the same thing. That's 7 plus 7 is 14. 7 plus 2 is 9. Plus 5 is also 14. This is an example of the associative property of addition. Now notice how the order has not changed. That's the first thing you should look at. If the order's changed, it's automatically commutative. The order stays the same, so now I have to look for something else. Third example, let's take 4 plus 0 equals 4. It looks like I start with the same thing I end up with. So the word same, I think of the word identity. This is the identity property of addition. Let's try 5/6 times 6/5. This one's a little tricky. I'm undoing what I started with. I'm going to end up with 1 here. So I'm undoing what I started with. This is the inverse property. I'm doing the opposite. In this case, the reciprocal. So this is the inverse property of multiplication, otherwise sometimes known as the multiplicative inverse. Same thing with the identity. This is sometimes known as the additive identity. Means the same thing though. Let's try another one. Let's try pi times 1 equals pi. It looks like I start with the same thing I end up with. So in this case, this is the identity. And this is the identity property of multiplication, or the multiplicative identity. And last but not least, let's try another one. Let's do 6 times x plus 7 equals 6x plus 42. In this case, it looks like I distributed the 6 to both of the terms, so this is the distributive property. Now, you'll notice that the distributive property does not have an addition and subtraction part of it, so it's just the distributive property. And that's it. Thanks for listening. Hey, you guys. It came to my attention the other day that the properties video that you're going to watch or have watched is missing 2 properties. So you will be able to fill out the top 3 tabs of your booklet, but you won't have any properties for the bottom tab. So I just wanted to go over real quick the
the last two properties. There's 6 in the video. There's 2 more here, so that's a total of 8. So these are kind of the easiest properties, really, that there are, maybe other than the distributed property, but the 2 are symmetric and reflexive. So the symmetric property says that if A equals B, then B equals A. It basically says that if 2 things are equal to each other, it doesn't matter what side of the equal sign you put them on, they're still equal to each other. So for example, if 3y equals 6x, then 6x equals 3y. It's pretty straightforward. This looks kind of like the transitive property. The difference is the transitive property has if, and then, but the symmetric property just has if, then. So the transitive property has 3 parts, the symmetric property only has 2. And then you have the reflexive property, and this is kind of the most straightforward property that there is. It basically says A equals A. So whatever it is equal to itself. It's very common sense, but you still have to state it. It's a rule. So for example, 8 equals 8. So that's the last 2 properties, and now you should have all 8 properties to be able to do any of the work that you're asked to do. So thanks, and let me know if you have any questions.